Hey everyone, Thosif here at the Plano District event here at 5411 RoboTalons, founder of the Prosper Engineering program with two other teams as well, 9105 Technotalons and 9492 Lady Talons, all came in at top 10 at the end of qualifications here at Plano. Really excited to talk about their amazing robot that they have, really fast elevator, coral mechanism, as well as amazing algae mechanism, and a butterfly style climb, as they would call it. Really excited to get down here on the behind bumpers. Isaac, talking about the design that you guys had for this robot, it's really compact. Everything seems to be max composite off the elevator, but talk about the ground up, from swerve all the way to your mechanisms.
Yeah, so starting from the drive base itself, we decided to go with SDS MK4Is because we realized there's these half field short cycles. So we wanted to prioritize, I guess, speed. So we wanted the highest free speed possible. And so that's how we ran with our drive base. And then this is, I guess, our central scoring mechanism. It's called our shooter box, and we designed it as we were prototyping. We figured out that there was a single angle that could score L1 through L4, and so we were like, hey, why should we pivot our shooter when we could just have a fixed angle shooter? And so that's kind of the design principle we were going with. And so this shooter box is made out of, as you mentioned before, max composite material. And so this is our first season using it, and we were able to, I guess, successfully integrate it into a lot of our different subsystems. And so this is our shooter subsystem right here, shooter box. And what's kind of unique about it is that, well, while we intake from our intake rollers right here, they're all powered by the same motor as the ones for our algae picker up here. And so if you notice down here, there's a nested max tube here, and within there's also a hex shaft. So this max tube is connected to a sprocket that connects to a Kraken down here. That's roughly 50:1 gear ratio, and this is able to pivot our algae picker. And within there's a nested axle that allows us to actuate all our rollers. And so this is our shooter subsystem. And then on the back over here, this is our, I guess you could say, butterfly funnel climb, where with prototyping, we looked at 118's design and we saw all the different ones. We decided, why not go simpler? And so we looked at this, I guess, kind of picker finger design, where we're able to notch into the lip on the cage so that we're able to winch in and climb. And we went with a winch design because we realized that, hey, why not leverage? You use mechanical leverage, kind of inspired by 118 as well, to pull down our robot. And so, yeah, that's the basics of our mechanical system.
Now, looking on your robot, your elevator, I see it's only being powered by one motor.
Yes.
It's a small package, but it's so fast. What's going on with this elevator over here?
So I'm sure programming can speak more to the speed of it, but we were doing a lot of testing, and part of what we realized is our shooter box can be made a lot lighter than we thought it could be. And so originally we were somewhere around 25 pounds, and that's cut down to 10 pounds. And so thanks to the lightness, even though it takes up quite a bit of a package, it's actually a lot lighter, especially with all the max composite. And so that allows us to move really fast up and down. And the next thing is we decided to go with a 2-stage continuous rigging from ThriftyBot. So we modified their elevator, and that allows us to go even faster and allows us to remain stable while moving fast.
So how much did you say this entire system weighs off the carriage?
Around 11 pounds.
11 pounds. That's insane. Now, speaking of programming, Anshul, talk to us about the programming that you have for this robot, how fast the elevator is, and talk to me about that entire process.
So starting with the essentials. So we have the algae picker here, which is a basic pivot, and we also have the elevator as discussed. So what we do is we run CTRE's motion magic on both of these, so we can essentially have the really fast 1000 hertz PID control with a profile to maintain extreme high precision while maintaining the speed as well. So we specifically we use recalc to make sure that our acceleration could be as high as it could be and hit off like all 60 amps of the motor. That's part of the reason why it's able to go so fast. And usually we set the max velocity above what the actual mechanism's max velocity is. So that way it's always at max once it gets to that top of its motion profile. We also have automation for the intake and algae picker. So
yeah, let's see that.
So for the intake, we have a laser can sensor here, and as soon as that sensor detects, we essentially tell the motor to stop and it can pick up. We have a similar system for the algae, where if the current spikes, the motor will stop. We can Okay. We have a similar system for the algae. Now the elevator, you can show the elevator scoring.
Yeah, let's see how fast this elevator is as well. It's so smooth.
Yeah, so on top of like just using the regular profiled PID, we also have some amount of what's called an S-curve PID where we tell it, oh, so instead of just instantly starting to stop, it'll curve into that stop and allow that smoothness to stay even while it's going as fast as it is, which is exciting. Now, that's the essentials behind our elevator. So now we can move on to drive base. Any other questions about the superstructure of the code? We also have LEDs to indicate to the drivers if it's picked up or not.
Yeah, what are the LED statuses?
So LED status, we have one for intake. So we use everything on a blink-in system. So essentially the concept is that we don't want for it to permanently indicate, oh, is it picked up or not? It doesn't give us that much information. Intake, right? So as soon as we pick up, it does like 1 second of like 2 blinks. The driver knows, and then he can go off and rest, and it'll still be looking cool by the end of it.
So you guys really use the Coral Station a lot with this entire mechanism, and it seems to work really well as well. Now, I want to talk about this entire Prosper engineering program that you guys have. So Kevin, talk to me about this entire Prosper engineering program that you have with Lady Talons, Techno Talons, RoboTalons being the founder. All of y'all are top 10 at this event. Talk to me about this entire program.
Oh yeah, we always strive for excellence. As you can tell by our name, Triton X. The X kind of represents our 10-year anniversary. You know, this is the Big 10.
Yeah.
We're kind of celebrating everything we've done. So all these teams, we're proud of the work we put in. We basically act as the mentor or the veteran team for the other teams, but then everyone gets to work on a robot that they make. Like, everyone works really hard on this stuff, and we try to make sure we serve our community because they serve us.
Right.
They're the only reason we're able to do any of this stuff. We have our sponsors, Argonaut and Optimum, who've helped us a lot over the past season and years, obviously. So we really appreciate everything they've done for us.
Well, congratulations. Thank you guys so much for taking the time to walk us through your amazing robot. Thank you, Jack, for being able to operate the robot as well. You guys are doing amazing. 10th year season, 10 year with your robot and your team, and also placing in the top 10 as well with all 3 programs. This is quite an amazing journey that you guys have had. Really excited to see you guys compete in playoffs with Techno Talons as well. So really excited to see you guys compete. So good luck to you guys, and congratulations with your amazing success so far.